guys. I always like, the 50 plus talks I have given, most of them are like, you can't even see faces, like, and some of them are just there to chase you out for a sales pitch after the talk. So I like this kind of setting, which is more intimate, and then you can have one-on-one conversation, more deep conversations about what's going on. And I am a new Miamian, so actually I can't call myself Miamian because I live in Fort Lauderdale, and then I just like drive every time I have to do something with Miami. But it's good, like, I'm trying to get into the ecosystem, trying to learn like what's going on here. So when I saw that there was this AI sort of events happening, and I was like, I reached out to Laura that I wanted to give a talk. I think it was 3 or 4 months ago. And I just like submitted a topic, and then there has been a lot of improvements and a lot of changes in terms of my thinking on how GenAI works. And as you might know, this field is constantly changing. Every week is something else. So it's just a learning of like mine as well, and like how we can build GenAI applications, what the main agenda of this talk is. So before we dive in, I just want to have a quick check of what stage you guys are at. How many of you have actually built a GenAI application and deployed it in production? 1, 2, 3. Okay. How many of you have deployed a prototype or developed something? Cool. Okay. Okay. How many of you are like thinking of developing something? Okay, majority. And those who are completely new to GenAI. Okay. Okay, so yeah, including Charmy. Awesome. So this talk is actually for basically broad spectrum, people who are getting introduced to the GenAI. So this would be like sort of a meta understanding about like different concepts around GenAI and how you can develop GenAI applications. And for those of you who have already deployed to production, this would be a good practice that you can take it back and implement in your teams for more iterative and more performant and resilient applications. So I think we have 1 hour to like spend on this, but the presentation is only 30 minutes. So we'll keep it very interactive, and then the most interesting part of this talk is the questions. So I look forward to learn from you, your curious like thoughts on this, and any feedback that would be helpful. So okay, let's see. Okay, so presentation has already ended. Okay, so the title, again, I have remixed it a little bit. I'm calling it the Lean GenOps Playbook, and we'll get it to a point like why it's called GenOps. Again, it's a made-up term. It's not popular yet. And my name is Aman Sharma. I'm the co-founder CTO of Lamatic.ai, which is a GenAI for DevOps company. And we'll get to know about the product in just a minute. Everybody can see the screens, right? I have to like, I think, walk back and forth again and again. It's better? Okay. So let's start with the story, like about my story of discovering GenAI and how I actually came into this sort of field. So one day, this is Chuck, my co-founder, and one day he came to me like, what if we develop an application using AI that helps you figure out what to have for dinner? Like a problem, a common problem that all of us have. And then it seems like, the solution should be just around the corner, but we never see like a app that has taken off and solved this problem of what to have for dinner. I mean, like, so the idea was like, what if you can have something like Spotify for dinner, which helps you figure out what to have for dinner, whether you are going out or cooking at home, and just like, have an easy playlist of whatever you want to eat. And then, we called it Dinnerfy, Spotify for dinner. And this is like the story of like how actually it came in being. So as soon as he came to me, what if we develop an application which had like a swipe-like feature, you left and right swipe, that helps you learn, that helps the AI learn about the user, and then you use that sort of to fine-tune and then recommend the the recipes and stuff like that. And then it can be actually used by the whole family, and then you can have collaborative feedback from all the members of the family, and then you can improve it further. So that was the thought. And as soon as I got to know, and then I was like exploring GenAI also at that time, and like any other sharp MIT engineer, I started thinking about how can I develop that using OpenAI, right? Like just write a simple prompt and then wrap it around my application, and my application would be an AI application, right? What could go wrong? So that was the thought, and as soon as I started thinking about like how would I solve that problem, I started getting into issues. Like, I started with a prompt 101, you are an helpful assistant, help me plan a diet for these family, and then trying to pipe all the parameters and all the instructions. But every time I tried a different approach, the results would be completely different, and the results would hallucinate a lot. I would give it like a cement chocolate pie, and it would give me a recipe, which is not cool because like it doesn't exist. So you have to make sure that how it doesn't hallucinates and like always responds in bounds. So I'm already having like troubles about like how actually I can build an application like this. And this is my typical workflow, like how I actually work. On the left-hand side, you can see Python Jupyter Notebook. This is me crying. And then on the right-hand side, you can see our food expert or the chef who actually is telling if the recipe is right or not. So I can tell whether the food can have a cement brick inside it or not, but I cannot tell if it's 2.5 spoon of salt or 2 spoon of salt. Like, so that's something that we need an expert for. So my typical day would look like that I would start writing a prompt, and then I will go to the expert and I will say, how is it performing? Then I will change something in the prompt, and then I will go back and forth. And Jupyter Notebook is pretty okay in doing that. Again, the interface is not really intuitive for the chef, but whatever. Like I'm burning the midnight oil, building an AI product, right? Then through this trial and error, I found that, actually better than writing prompts, it's much better to write chains, which is basically breaking down a big GenAI problem into multiple smaller problems, and then using response from one prompt as an input for another prompt. So, through that discovery, I found this framework called as LangChain, and this is like a year ago. So at that time, LangChain was pretty unstable, and if you have used LangChain at that point, salute to you. Because it was very hard to like really see what is documented and what's not. Sometimes you will end up tracing a function, and then at the end it would be just a null kind of return call, right? So that was a very difficult part for part of my life, whether to do like it with LangChain or not. So and then in the middle of everything, I developed all my prompts for ChatGPT 3.5, and ChatGPT 4 came, and everything that was working on 3.5 wasn't working on 4. Right? And these are like even small issues, like, okay, the response would be better, but it would be slower, and then in that slow time, my timeout would happen, and then the response won't get in the right proper time. So I ended up actually, doing a hybrid approach in which few of the prompts were running on ChatGPT 4 and some of them were running on 3.5. But okay, I can survive this. In the middle of all this, I also got to learn that, okay, it's not really relevant to always generate responses, and also you can use this approach called as using vector database and approach called as RAG to help you insert contextual data, or maybe cache some of your results so that you don't need to go to OpenAI to return response every time. So if somebody has a similar profile, or somebody has a similar requirements, you can just fetch a recipe from the vector database and respond back. Okay, a new thing, but I can learn, I can solve this problem, I can still get my application up and running. But there are more problems, like the more systems I'm adding to my whole GenAI application, the more complicated it's becoming. Even if there is one API call that doesn't respond within time, my application response won't actually come back, right? And I don't know what exact prompt is actually causing that problem, because it's OpenAI basically, which is running all these prompts, and then I have no idea about how the system works. So long story short, and everybody knows this, that GenAI POC is easy, but production is hard, right? Everybody agrees, right? That's the reason why startups are the only one that are doing it, because everything is in prototype, and enterprises are sort of scared of using GenAI because they don't want to launch something that doesn't like works well. And this is something that I learned after going through this, I think 3 or 4 months journey of discovering what works and what doesn't work. Well, eventually we ended up launching the application, which is performant, which is right now online, dinify.com. You can start using it right now. And the same concept that we imagined, it actually works in practice. So your family members can give reactions, and the app learns about the feedback and likes and dislikes of the family members. And then we convert the whole sort of dinner list for the next 7 days into grocery list, which you can order on Instacart, Amazon Fresh, and Walmart. So it's like really a one-click solution using GenAI and using custom UX to solve that problem, right? So this is the exact story of what helped me launch this product stably in production. And I think, so we launched on Product Hunt. We became Product Hunt Product of the Day. We got 5,000 signups on the first week itself. The app is still performant and production ready, and we have very low OpenAI expense if you are thinking in that direction. So this is basically like how we actually optimized it. So a lot of you might be thinking right now, what exactly was the solution, right? Because if there is a magic wand that you can use to build GenAI application and those are productionally stable, that seems to be the solution to all the problems in the world, right? So this talk is exactly about that, and that's what brings me to introduce my company, Lamatic.ai. So the interesting thing was when we developed Dinify, we actually developed so much of DevOps to make things stable, and there was nothing out in the market that we sort of realized that maybe the DevOps or the whole platform engineering that we did to deploy our application is much more valuable than the app itself. So in the week one, as soon as we launched the product, just out of curiosity, me and my co-founder discussed this with other startups as well who were using OpenAI and were developing GenAI applications. And out of nowhere, we got 5 paying customers in first week. And they were like, yeah, I'm sold, just build my application, right? And we didn't have a product, so we had to fake it a little bit. Like, we would do what we call in technology dog fooding, which is basically we are a team of people working in the back end to actually make that work, and what they are seeing is a facade. So we did that for a couple of months. And today we launched our production application, version 1.0.0, which is available for public use. So it has been a huge journey for us to learn and see how we actually develop that application. If you're interested, here is the QR code. It includes the link to the slides as well as the link to the sign up if you're interested in that. And you can obviously go to Lamatic.ai and get a demo of how our product works. We are looking forward for some early private users right now. Awesome. So enough of the sales plug over here. I'm going to talk about like exact kind of crux of why I'm here. So this is our DevOps cycle. How many of you are familiar with this? Have you seen this Mona Lisa painting before? Yeah. Right? I think an engineer might have missed seeing a famous Mona Lisa painting, but not this one, right? Like this has been sort of the pudding for last 1 decade. It's a good cycle. It helps you deploy application really fast, basically achieving the miracle triangular balance of CI/CD. And then there is nothing wrong with that, but there are some problems why it might not be the best approach for GenAI. And just to give you a context, I have been specifically focused on DevOps for the last 7 years of my career. And I'm also a DevOps expert ambassador with DevOps Institute. So my thinking about ditching DevOps was actually very anti with my community. And they were very sad with like, why are you actually killing the whole DevOps idea? But just let's see what happens. And then what I did actually was like through this trial and error of working with early stage startups, I actually had another approach which I developed on top of DevOps called as the lean DevOps on how DevOps can be used as startup. And even that one is still not really ready for the GenAI wave because things are just different. So what exactly is different in GenAI, you might ask? So the first thing is like the biggest kind of ghost in the box is external dependency, right? This is the first time in technology that there is this outside tech that we are using without knowing how it actually works, right? And then when that happens, you are basically sort of always guessing that whether what you are doing is right or wrong. So this ghost is obviously very kind of alarming, and that's one reason why, one of the biggest reasons why actually GenAI applications sort of have the issues that we see today, that you don't know what that external dependency really is. Then the second thing, which is a piece of understanding that I had, is like building a GenAI product is not just an engineering problem. It's also a domain expertise problem. For example, when I was building GenAI application with Dinify, I was knowing everything about REST APIs, how to do API calls and stuff like that, but I had no idea about how to actually cook food, or how much ingredients goes in what, or how to create a meal plan and stuff like that. So I had to actually have a domain expert sitting next to me and collaborate with me, and they can actually read prompts and they can tell me, hey, this is not the right prompt, you have to optimize this prompt for this. So in most of the companies, if you have a non-tech founder or a non-tech product partner, you would see that they are actually better at writing prompt if they are domain expert in that domain, rather than you who only have engineering. More about domain knowledge and understanding how the system works than technology alone. So this is the first time that we are having different people collaborate on the same stack, both non-tech and tech. There is this compound effect problem, which me and Stephen was talking about. Like if you do one thing wrong in one system, that kind of creates a kind of compound effect with other things. For example, if you are using fine tuning and your data is bad, then it will actually, the training would be successful, the result score would actually come good as well, but the actual content would be hallucinated, or it won't have the right actual factual correction if you are thinking in that direction. And also chains specifically, if you are using chains for prompt, and if one prompt actually has a bad response, then all the downstream chains will actually get that bad response as well. So that compound effect problem also is like a big challenge over here. And this is the first time in the technology industry that we have literally just one piece of technology, ChatGPT 4o. That's it. There is no other customization, and every company in the world is actually using the same model. Isn't it like kind of like fishy? Like there has never been a time in technology when you actually get something out of the box and don't even modify it, use it as it is. So so this is actually a big problem, because you are almost trusting a company like OpenAI that they would be solving your problem. But imagine how many different industries, how many different departments, how many different types of use cases exist, and how many edge cases can happen. And imagine one model actually solving all of that. So that custom fit problem is actually a very big challenge, which is the root of all evil, as you say. And then the iteration fast is really, really important. You don't want to fine tune a model and then later realize ChatGPT 4o is much better than what you fine tune, right? Like, so you're always battling and racing between do you want to improve a system that other company would just like, you know, like Sam Altman says, steamroll you, right? So you have to always make sure that you know, your speed of execution is really, really fast, and you are at the edge of what's happening. If you're just like chasing along what updates are happening, that's not a really good spot to be. So due to all these reasons and a couple of more, I think DevOps is not the right fit for applying as a framework for developing GenAI applications for a couple of reasons. First of all, there is no code. It's prompts, and the only code that you're basically writing maybe is a little bit of for loops or if logics, or just piping prompt from one prompt to another. There is no build step involved. The build is done by OpenAI itself, and everything is runtime. So there is no sort of predictability and response that you can you know, lock in a state, and then you can expect the system to just work outside the environment exactly like that. There is not something exactly as test, but more like evals, where you evaluate your responses and models against some test cases. And then finally, you don't have any release step which is internal. There are, even if ChatGPT labels a model as ChatGPT 4o, they are constantly releasing even that model itself as well. So the quality release is not actually a factor that you can control. So that's basically where the release step is like completely sort of out of your hand. So what is the solution if this is not like the right DevOps? DevOps is not the right solution to that. So we need something new. Any ideas or something that you have used at your companies that has worked very well? I want to capture your imagination before I let the cat out of the box. Anything? Something that you used in your company that worked?
Nothing that worked well.
Okay. Anything else?
Honestly, just taking an iterative approach is the only thing that's worth making in progress.
Yeah, yeah. But how much iterative? Like, is it?
It can be painful. It's, you know, it's like drilling down a prompt. You know, if you put everything into the prompt, you're not going to get what you want. But
yeah.
It's knowing that you're going to take, you know, 5 steps, 10 steps through that prompt.
Right. And do you think? So do you think the upsides of using GenAI with that downside of like needing to constantly upgrade everything, is that worth it? Still?
Oh, that I'll let you know. I don't know.
All right, so I would say it's more like empty canvas, and let's see what exactly I have in mind, and then again you can give me an honest feedback about what you think. So this is what I actually built. It's I call it the GenOps cycle. GenOps because DevOps for GenAI, combine both of them. That's the obvious first word that comes, and it's a 8-step cycle to do exactly what you said, Gaston, around iterating things really fast and making sure that you don't lose the track of what's happening outside the domain, or just iteration is like the #1 reason. And so it's 8-step process between plan, model, workflow, evals, data, deploy, operate, observe, and then repeating it over and over again. And again, when I started the talk, I said like this would be sort of meta understanding. So if some of you don't know these terms, it's completely okay, because I'm going to take a very introductory approach and going to help you. So if you have, you're not engineer, but you are like a business owner or something, this would still make sense and will help you communicate with your technical person and have a much more better understanding about how these systems work. All right, so let's get started about what this cycle really is. So the first step in GenOps cycle is the plan, which is basically about figuring out these 3 things, which is input, ability, output. And input is about like what exactly a user is inputting into the system. Like what exactly are you getting it inside? Is that an image, text, very high level thing? And then is the response gonna be a JSON or whatever? So it's like it's the easiest thing over here. Then what ability exactly are you looking for from an AI system? Are you looking for it to give you some certain steps? Are you looking to generate an image or a video? Are you looking to transcribe? Are you looking to summarize something? And it's also important to break down the ability into individual tasks. Like thinking about, okay, I have a high level thing. I want a call bot that helps me analyze my video calls. But you have to divide it into multiple tasks. I need something that converts text to speech. Speech to text, and then text summarization, breaking down the sentences and all that. So divide them into tasks, and then output is finally, how do you want to respond to the user? Is that a live chat? Is that a feedback loop, or is it an image generation? Is it a one-step process? What that output looks like. Based on these 3 input, you will form these 4 decisions, which would be sort of the overall blueprint of your GenAI project. Again, you can change it over time, but the important thing is to have sort of a overview and understanding about how this thing works. So the first thing is operator. Operator is basically in what mode your application is operating in. Is it completely automated, like Dinify, where there is no human intervention at all? Is it semi-automated, which is there is some intervention involved sometimes, but most of the things are still AI? Or is it assistive? It's basically a backend that some B2B enterprise customers might be using, and then the actual user is just getting a flavor and outcome of that. So decide what's your operator mode. What I have realized is it's always a better approach to go from here to here to minimize the risk of damage and public humiliation, right? Because we have all seen that stories of how GenAI just goes rogue and starts blurbing. The second thing is interface. There are 3 main interface. There could be more, but ultimately these are the 3 buckets that fall into. Is it mostly chat? Chat is one of the most common way to interact with GenAI system. But you can also think about custom UIs, like how Dinify doesn't have a chat system at all. It's just UI, and then we are just creating that UI as an easy UX for the person to interact with the system. Or there is this new thing around the town, which is called generative UI. How many of you have heard of it? Generative UI. Right, so this is something that Vercel has been like kind of cooking. There are other companies that are getting in that interestingly as well. So it's basically like instead of just blurbing out the text, how about we convert that text into a UI just in time that a user can understand, right? So for example, when I ask ChatGPT what is the weather today, instead of just saying it's 25 degrees or like 78 degrees, what if I can create that Apple-like widget for the weather? That's basically generative UI. So something that you generate on the fly for the user. So this is like kind of new kid around the town, but has amazing potential. Then your data, the contextual data that you're providing to this system, is it unstructured? Is it structured? These are the main two categories, but there is another third category which we work all the time, which is like logs or telematics data. For example, you have a lot of logs, you want to analyze that using AI, and this is the hardest category. Again, like this kind of flows in this direction as well. And then the final answer that you will get to is what is the model that you want to select. Sort of a very high level understanding about what kind of model you want to choose. It's not exactly what model, but what kind of model. So modality, is it a text, image, multimodal, or video, whatever modality it is? What is the context length? A lot of you might think that having biggest context length is better, but it comes at a high cost, and also bigger context length models are like more prone to hallucinate than the smaller context model. So kind of a middle ground, like if you only need to respond a user with 10 words or something, maybe having 2000 token context doesn't make sense. So kind of like a best of both worlds. And then finally, what is your use case, right? Are you thinking about going private or open source, or is it for healthcare? So depending upon that, a lot of decision will change around what nature of model you want. Do you want private model? Do you want open source? Or you are okay with something that comes off the shelf from OpenAI? So once we have formed these 4 kind of decisions, we start choosing our first model. And by the way, you will also notice that I have actually attached this emoji as well. This sort of shows you what stakeholders are involved in that step. So if I go back to the previous step, I don't know if you noticed or not, this one is just your product manager, or it could be you and the customer who is the stakeholder. So it's like a back and forth collaborative process between both of them. And then the model selection is basically a collaboration between product manager, data scientist, and the developer, right? A model can be selected based on these 6 parameters. So again, you have that answer that you got from the previous results, and then we are going to have these decisions formed as well, which will help you choose what model would be the best. So you have modality, again, simple, the easiest one, text, image, sound, video, whatever. Then context length is the easy one as well. Then the privacy is the easy one, whether you want open source and all. So this kind of filters out a lot of model selections for you. Then you go into the more sort of kind of qualitative analysis of these models. There are still not acceptable benchmarks which are widely acceptable around the LLM models, but there are good benchmarks from I have attached 2 links over here. One is from Martian, and then one is from Glimpses, which kind of helps you compare quality of different models. But some of the quality parameters that you might want to look into is performance, which is measured in how much tokens responds within seconds. So what is the speed of response from a model? So this is also documented and tested over and over again for you to know what's the speed of that model. Then the quality. This is the hardest to measure, right? Because it's a human thing to measure and say if a LLM or a model is hallucinating or not. But there are still like other benchmarks, for example, HelloSwag or chat context or CRM sort of benchmarks, which help you analyze the quality against some test cases. And then finally, it's the price, right? Like what price you are willing to pay for it. Again, there is a fine balance. GPT-4 or ChatGPT-4 might be the best model, but it's the most expensive as well. So are you willing to take that cut, or what's the sweet spot? And often the case would be that you would end up choosing multiple models, and it's a good thing. And we'll learn it in a like why it's actually a good thing to choose multiple model than to just like make one short kind of decision and use all these models in your product. Once you have chosen the model of your choice, the step 2, and this is an optional step, you can completely use the model out of the box as it is. But just to improve the performance a little bit better, you can actually go ahead and fine tune it. And then fine-tuning also has 2 different types of fine-tuning. One is called full fine-tuning, and then second one is parameter-efficient fine-tuning. So I'm not going to go too deep into the technical architecture of what this is, but just to like let you know how this actually works. So full fine-tuning is getting something that is open source base foundational model, and then applying your own sort of custom data on top of it to add more context and kind of generate. And the easiest sort of use case in these scenarios is basically just going to Llama 3 and then taking the base open source model and then using their fine-tune kit or SDK to actually apply examples and then fine-tune it. And this can be relatively expensive, and it also requires some technical skills in order to like completely frame the data right and then apply that. Because again, the fact is like if you give it wrong data, the model is going to train no matter what, but the quality of the model would be trash. then there is a better approach. If you don't want to fine-tune, you can use the parameter-efficient fine-tuning, which is fine-tuning that you do in real time or in the lifetime of a model. So this is something that ChatGPT or OpenAI gives out of the box for most of their model. So you would have noticed ChatGPT 4 and then ChatGPT 4 Instruct. So you can basically fine-tune these models with your own custom example, just using their own API, and then that helps you actually, of course, that's the best of both worlds. You don't need to do full fine-tuning, and the only thing that you have to do is just give it pair of responses. For this question, this is the answer. For this question, this is the answer. It's not exactly sort of learning those use cases. It's training itself to respond in that particular kind of language. It's not really good for factual information, but if you want to change the tone, the personality, or the type of response that you get from the model, this approach is usually better. Yeah.
What about RAG?
Yeah, we'll get to that. So like RAG is not a fine-tuning, and there is a lot of consensus on Reddit that says RAG is a fine-tuning, but it's not. So I'll get to RAG in a minute, but it's not a fine-tuning with the model.
The actual model, right?
No, it doesn't. No, this does change.
Changes the model.
This, yeah, if you see in this diagram as well, like this is obviously like it's changing the model weights, but if you see this one as well, when you provide domain-specific data set over exact extract models, it actually changes the weights. So what we are really changing with these models when we say fine-tune, we are changing the weights of these models, like how they respond in a certain situation. And when you apply RAG, there is no weight change. It's basically just giving more context to the model. But this actually changes the weight, which may or may not introduce context, but it definitely introduces personality and quality assurance in some cases. But it's a very domain-specific thing. This approach works for certain domains and certain not. So we already talked about full fine-tuning and parameter-efficient fine-tuning. Then this is the most important step, and this is where everybody actually starts their journey. Not the first two steps. Let me write a prompt first, right? Like, so this is what I call the workflow. There are different ways to call it. Some people call it chain, somebody call it flow. Just for my ease of reference, I just call it workflow. And then for this step, you would need your product manager, your domain expert. This is where your non-tech person actually comes in, and then your developer. And there are basically 3 steps to gradually improve your workflow process. You start with a normal prompt, a single iteration, then you go over to chain, and then you go over to agent. So we'll go through step by step what exactly all these 3 characters really mean in a workflow. So the first one is prompt. This you already know. If you are using ChatGPT, what you ask ChatGPT is basically the prompt. It's kind of a trigger, and then after that, it just responds back. So I'm not going to go deeper into it, but this is like a worldwide acceptable. It's good, but it won't actually help you provide really good data, or it doesn't have sort of a lot of self-evaluating and self-correcting kind of thinking. What you are really interested in is chain. That's where actually the real thing starts. So there was this discovery of what we call chain of thoughts. If you can break down the problem for LLM at different steps, and instead of just like feeding one single question, what if you ask it to like kind of divide the whole problem into multiple steps, like how we as humans also kind of do things. If I have to come from Fort Lauderdale to Miami, I cannot just like fly here, right? I will take I-95, then I will take an exit, and then stuff like that. So the same way we are doing with LLMs of how we can break down a problem into multiple chains or multiple prompts, and then response of one prompt will act as an input for another prompt. And then you can also introduce custom data in that to give it more context. So that is what will actually form chain. Again, LangChain is a very popular LLM model to sort of framework to actually build chains. But there is something even better than this, and that is called, before we jump into the next thing, the key to like create good chains is thinking of it as breaking down the problem. So this is what a typical approach looks like, which we call thin wrapper, right? You have data, which is the input, and you just put your prompt, give it to LLM, and then expect a response. This is like a horrible approach. What you really want to do is like you want to break down the input data into multiple prompts, which you may run parallelly or serially, depending upon what exactly is your problem, and then getting it to the right application. And why this approach is better? Because it's flexible, it's cheaper, it's accurate, performant, and customizable. The most important thing, if let's say you want a response that is 2,000 tokens, and you use this approach, if one token fails, your whole response gets damaged. But in this case, you can divide the problem in such a way that if this fails, only this needs to be retried. Right? So that has more control, more customizability, and often will end up giving you more performance because parallel things runs faster. And also, it's more cheaper to retry only one thing over the whole prompt. So That's sort of a high level TLDR. What you might be really interested in is the agents, which is sort of the new kid around the town on building LLM models. So if you give a chain ability to self-think in the process when it is giving a response, that's when you get an agent. I'll explain it again. So in these examples, you can see we actually did two new things to the same chain that we were building before. First, we have given it access to tools, and this is different than just giving a if-else loop and asking it, okay, go and do this API call. This is not function calling. This is basically in real time asking it, okay, you have all these tools available. What do you think is the right tool to pick, and then use this tool to your advantage in real time? That is what an agent is. And of course, you need to fine tune, you need to train it, you need to give it certain examples, what tool to use when, you need to give it documentation, you need to give API request, all of that is there. But it is choosing that tool in real time, and it's making that smart decision. The other important thing is that an agent makes choices. This is the biggest thing it makes difference. So instead of relying on a human, how about the agent, sort of the LLM act as a user itself, and then responds back to its own response, and then work back and forth to divide and conquer the problem. That's when you get agent. Again, there are like really great videos on how to build agents. I'm not going to go deep into that, but just on a very high level, if you're thinking of developing agents, you can use Microsoft AutoGen, and LangChain actually has an agent system and framework as well to build smart agents. Now we come to we have our model selected, we have our workflow selected, and most of the people will call the job done, because when you are building workflow, you are doing a little bit of inferencing and iterations at that time as well. But it's important to have a step to do evals independently before you actually launch the product. Eval is basically trying to evaluate what is the response and the quality of your workflow and GenAI system. And it's actually a fine balance between safety, robustness, and correctness. So safety basically does it not slurs out or says bad stuff. Then you have robustness, which is it always responds within its own limit, confined limits, and it's always responding in JSON format if that is the system that you are using. And then obviously correctness, the facts are right, it's not hallucinating. And it would be a lot of sort of trial and error. And this is where we come to the closure of our first thing, which is the experiment loop. So again, we picked up a model, we did build our workflow, we did our eval, and then we'll go back to our model step unless we are kind of happy with our performance. So this would continue to go on unless you are satisfied. And once you are done with experimentation and the eval results are quite good, you have a fine balance between the three triangular safety, robustness, and correctness, then we can go ahead with the fourth step, which is basically data, and that's where we come into RAG. Now, this is a very controversial thing. I've given both kind of mixed comment that it makes sense to actually introduce data later on, once you have figured out the prompts. And some people have said, no, you need to have RAG as the step in day one. But my personal opinion is that RAG, again, doesn't improve the quality of content, it adds context. So you might still have bad outputs and bad prompts, and the RAG is not going to do anything better for that. It's just going to add more context to the problem, but you want to make sure that your prompts and workflows and models are right before you get into the actual data integration step. Because all the previous steps are actually about quality and response, but this is the step of adding context. So that's where the differentiator happens. So for the data step, and this is basically an expansion of RAG itself. I didn't want to put RAG over here because some people get scared with technical terms. So this is basically integrating your data. And this would require your product manager, data scientists, and developers to come together. So it's a three-step process, basically. Getting your documents, chunking the documents, and then embedding the documents. And we'll understand these step by step what these really means. So the first step basically is you might have a data source. It could be unstructured data. It could be structured data. What you really want to do is basically map the data and serialize it. You can't just throw a SQL or structured query language data, which is basically relational data spread out. You want to merge it together, flat it out so that it's all packed into one context. And then you want to divide them into chunks. So what are chunks? Like the high level kind of chunks sort of definition is that LLM has a context problem, and then you can't feed the whole 100-page document as one single prompt. So how do you efficiently divide data into smaller parts, which doesn't loses the context as well, so that you have a context between one packet and another, but at the same time, it's efficient enough to be passed down to LLMs. So basically, it's a kind of a trial and error between seeing the chunk size, what chunk size actually matter. Chunk size is usually measured in tokens, how many tokens you can pass in one chunk. And then you also need to think about overlap, which is a very good strategy, which is like I would actually have a last part of my chunk as a starting part of my next chunk. So there is never like a missing context from one chunk to another. And there is things called as chunk serialization as well. If your data is like, let's say if I'm doing a storytelling and there is a story that I'm getting into a chunk, I want to make sure that the first chapter of the story is fed first and the second chapter is fed second. Otherwise, LLM will think the other way around and it won't have the context. So that is called chunk serialization. So once you have chunks, you want to use some kind of embedding algorithm. This is sort of easy pick. If you don't know the answer, just go with OpenAI's embedding. It's not that expensive, it's cheap. But if you have a lot of information, a lot of data, then you might also consider open source embedding models like BERT. And once you have embeddings, then you can just put these embeddings into a vector database, which is a special type of database to store embeddings or vectors. And then you can use them into actual querying. And it could be basically you have a query, and then instead of just giving response out of LLMs, we ask LLMs to actually get the context from the vector database and only respond within that context. That's basically what RAG really means. Once you have integrated your data, now we are onto our steps, which is mission accomplished, which is actual deployment. And this is where there is an overlap between the deployment step in GenAI and the deployment step in DevOps. So again, the same best practices that we use in DevOps should be applied over here as well. Have a good version control of your system. A lot of people don't manage their prompts version controls. So there is no way, like things might be working and then you get to a point where things are not working and you don't know what exactly was working at what point. So have built-in version control system. Try to containerize application. It definitely reduces it. Containers hosting doesn't cost much, but let's say you have a container, then you do a rollback from ChatGPT 4 to 3.5, which I actually did. Instead of rebuilding the whole application, I just need to swap my container and that's it. So that's a good approach as well. And then recently I have started experimenting with feature flagging, which is basically when you change something in the system, flag in the analytics and see what the response are. And that will actually help you have good telemetry and understanding about how your deployments are creating repercussions and results in the actual production. After deployments, it's the operation mode of your product. Operation mode could look like in these 4 stages. One is the normal response, not involving AI. The second one is autonomous response, the most scariest one, in which the human is just directly talking with the AI systems and responding back. And then you might also have assistive response, in which you have partially autonomous and then a human is grading whether this result is right or wrong. Could be difficult to maintain, but at least is much more reliable. So this is like the approach that I usually recommend, and then the last one is finally like a complete human response. So kind of an easy step on how it depends, like how would you install the application, and depending upon like what your operation mode is, you might need to change a few things around what is the visibility of your prompt, how people interact with the system and stuff like that. And then finally, you have observability. So once you have deployed your application, don't wait for your customers to say bad things to you. Have a real-time analysis of how basically these systems are performing in real time. If you have compliance issue, then this might be difficult. But if assuming that you don't have a compliance issue, and then you can look into actual queries that customers are doing, it's highly recommended to rely on traces, which I want to start with. And then another thing you want to always have in check is real-time alerts. All the systems that you are working on, you should have real-time alerts from those systems. If ChatGPT 3 is going down, you want to be aware of, on that, instead of that system just creating kind of a ripple effect and then pushing a lot of garbage in your logs. You also want to monitor uptime, performance, what we discussed in terms of latency of these systems, quality. This actually is a screenshot from this product called as Honey Hive. which actually has a solution to measure hallucination in real time of your LLM model. I don't know how they do it, but they do a pretty good job. It's kind of accepted, so something you can try it out. And then you can also analyze, keep a check on the cost. You don't want a $10,000 bill from Sam Altman, and then let's say your GenAI startup is bust, right? So you want to analyze the cost and quickly make maneuvers, like whether you want to keep using that model or you want to switch to something else. A good framework that I have found, open source LLM observability tool, Langfuse, which we use at our company as well to do a lot of telematics and observability. And it has most of these like analysis except the quality one. This one is from Honeyhive, and that one is not open source, so that's why I didn't actually put up a logo over here. So that's basically it. That's the GenOps cycle. So based on your observation step and the operation step, you would have some kind of insights, and then you can use those insights as sort of plan for your next iteration. So you guessed it right, it's actually about iteration. So it's a very iterative process, like very fast you have to move. You might have different people working at different steps, which is actually a good thing, but you got to make sure that you pass the context from one step to another, and that works. That's basically it. And my few TLDR and best practice, if this was to sort of stretch on a single topic, it would be like these 5 points. Think of this as like foundational DevOps. Again, a lot of steps are still from the DevOps cycle, but it involves iterative thinking, right? Like you have to apply a lot of iterative thinking instead of just saying that I'm going to release and then everything is going to work fine. Plan ahead of time to avoid potential pitfalls. The POCs could be really a big mirage. It could be really lucrative and good thing to call your product a success, but you got to plan ahead and see what is the highest sort of quality benchmark that you have to go through. It might be very easy to get the quality from 0 to 60, but it would be impossible to go from 60 to 65. I've seen those cases. So you got to plan ahead what is the acceptable quality in your domain. You also want to have a very collaborative culture, right? Like you want to involve both people who understand non-tech but are domain expert to come in as prompt engineers and use the systems directly. You also want to include data scientists in the process. And investing in tools is really important. All of what I said can be done with just a single Python fast API, Flask API process, right? But that won't be a right thing to do personally, what I have learned about after developing Dinify, because there is no visibility, there is no like step challenge, there is nothing I can actually control over these variables. And then the final one is stay informed. I have subscribed to almost 10 newsletters now about GenAI, and every day I learn something new. So it's really important to stay ahead of the curve, what we talked about previously as well. It's a very fast iteration, fast moving kind of cycle. You don't want to be left around. So make sure that you have a good signal coming in through you, and you can use these insights in actual product. So that's pretty much it. And thank you for being a lovely audience, and let's start building.